Hi, I just want to go through some things I've been doing with the Hilbert Filter Design. And what we'll be going through is two different methods. One is using the Hills Hilbert Filter Designer, which I'll show you where to get it, and you can graphically design your filter the way you want. And I'll also go through some how to do it in Python at a much lower level, if that's what people are interested in. So we'll start with the Hills one, and basically, this is how you can graphically adjust this to whatever you need. But probably the most important thing is how to get this, because it's not readily available anymore. So if you go to the Wayback Machine, I'll put a link in for this. And the reason I'm not just sharing the actual software is if you look under the license agreement, redistribution of this software is not permitted, so we're not allowed to share it. But it is open. It is GNU software that you can use. So if you go to this link, you get an example of all different types of filters: designer, analog, digital. Highly advised that you download these and store them away in case they go missing. So here we got lots of theory on the Hilbert filter. I'll let you read that yourself. But the most important thing is available on the download page, and you can just download it here. And for Windows, it's very straightforward. You just run it as a normal file. For Linux, what I'm using Wine to run it. So once you've that done, and you start it up, you basically, let me start it from scratch so that you can see what's happening with it. So just going to run this with Wine. Wine is basically a Windows emulator that runs on Linux, so it allows you to run Windows programs under Linux, which is really handy. So I'm going to do a very simple, well, maybe simple is the wrong term. I'm going to show you how to adjust this very simply. So the the sampling frequency, that needs to match. So that's 44.1 kilohertz. So that matches what we're doing on the ESP32 and the I2S DAC and ADC. So I'm going to bring this down to, we'll say, 1.5 approximately. Maybe 1.7, and then I want about 2.8. Sorry, for bandwidth. So I'm just going to adjust that down. And actually, it might be a little bit too much drop off here. So, and the number of taps I've been using is 161. That seems to work well. You get nice steep curves there. So our bandwidth 2.87, center frequency. So this will basically shift this over and back. So depending on, let's say, our minus 3D point here is 20 hertz, is it? Yeah, give or take, and the 3D point here is 2.4 kilohertz. But by adjusting the center frequency and the bandwidth, you can adjust these over and back. You can play with different windows here. Sciencey seems to be the best, nearly, and you can play with the steepness and so on of the curve, of the drop off. So once you've that done, you basically just save your coefficients. So in this case, I'm just going to call it. This is a plus 45.txt. We need to generate one for minus 45 degrees as well. And if you haven't seen it, I put up a video on exactly why you need to shift this 90 degrees. So have a look at that if the reason for doing plus or minus 45 doesn't make sense. So we just save those coefficients as well, and we just call it minus 45. So then if we go to sorry, just going in here to, so let's have a look at these files. So it's under users, Ash, my documents, IO Hills, Hilbert filters. So these are the two text files that we generated, and I'm just going to copy them, and that's that guy. They're both in the same place. Why is that? Not sure. So we take those two files and we can just copy them into where we have this add comma function. Because if you look at these files, you can basically take. Let's just open up this. So it's just 161 numbers. That's it. And there are the coefficients for the filter. So when we want to do the digital filter, and I've set up there's a coefficients.h file. So you can basically just put the 161 numbers in here, just like this, with a comma after each one, and that will give you, and just name this to something that makes sense. And you do the same for the minus and for the plus 45. And then in the actual code itself, under setup, you basically just put in that array there and here. In this case, if it's SSB, and then first you can create a CW one as well, or anything that you ultimately like. You're in full control here. So you just set the filter, and then it's just going to process the audio input using that filter. So it's that straightforward. So I have a function here called add comma, and it just makes life a little bit easier. So if I open that and go Python 3 add comma. So we'll do it for the p45.text, and then p45 modify.text. And so it just gives you this. So it basically formats this. The only thing it doesn't do, it doesn't put a semicolon at the end. Just be careful. You need to manually add that. So if I copy all of this and go to my Arduino, into my coefficients.h, and basically add that, give it a sensible name. So I'll just say so EI8KI filter. So this would be on this is positive. So then if you did the same for the negative, you just basically take that name and you put it in here. That's it. It does say here, so just swap the coefficients to change sidebands. So this is set up for 40 meters. So if you're on so it's lower sideband. If you're on upper sideband, just swap the 1 and the 0, and that'll swap the sideband for you. So that's how you use the IO Hills software. It's very straightforward. and should close it out, save it. Sorry, just going to clean up here. You should be able to play with filters yourself, and then just close all this. If you want to go deeper into this and really understand what's happening, I've created a Python script here that allows you to do some stuff. Now, right now, this Python script only does low pass filters, so it'll do 0 to 800, 0 to 2.8 kilohertz, or 0 to anything that you want, basically. I haven't got the bandpass part of it done, so if I wanted to go from, say, 700 to 900 hertz for CW, then it won't do that. So the IO Hills will. But basically, you just put in your this is all you have to specify in it. So keep sample rate the same, unless you're going to start changing that in the Arduino. So just your bandwidth and the number of taps, the order of the filter. With the help of lot of research and so on, eventually figured out how to design a Hilbert filter. It's not very clear in a lot of places. So you basically design a low pass filter. You run it through this thing called a Hilbert transform, and then that'll give you a 90-degree phase shift. And then in this case, because we want plus and minus 45, we have to adjust the taps, and that's pretty much it. Just save to a file. So we'd save the plus and minus 45-degree phase shift to file, and that's what we get. This is really for people who want to dig in deeper into the theory behind filters and so on, and really do it from scratch themselves. If anybody has time to put a GUI around this, that would even be better. Because I said the IO Hills, I'm not sure, it doesn't seem to be supported, but it's really good software. So then if I run this then and say Python 3 generate Hilbert filter, so that's going to run this file. So what it does is it generates the file and plots it. So the plotting is down here. So it's going to show you this is pretty much what you're going to get. And I've tested this and it works perfectly well in the Arduino as well. It's just slightly more convenient because it generates the plus and minus for you automatically, and puts in all the commas and the semicolon at the end. So the only thing you have to do is just give this a unique name and put it into the Arduino. So that should get you started. Obviously with filter design and DSP, there's volumes and volumes of work on it. But if you've never done it before, you should be able to do it after, if you just follow these steps. And the IO Hills is really good because you can just play with the controls until you have a shape that you like the look of. And then you have your own unique filter for whatever application you're trying to do. So I really hope this helps. And but obviously, by all means, just ask questions. I won't promise I'll know all the answers by any stretch of the imagination, but somebody in the group may. So thanks for watching. Really appreciate it.